Floating in the absolute dark of our oceans and buried deep within our soils are shapes that defy logic. Spheres of glowing green tissue, vibrating rings of pink flesh, and skeletal jaws that seem to detach from their frames. When we encounter biology this bizarre, our instinct is to view it as an error, a glitch in the genetic code, a creature that evolution somehow got wrong, leaving it burdened with a physical deformity. But natural selection operates strictly on utility. We are going to look closely at 6 apparent anomalies of nature, structures so strange they appear broken, to reveal the specific environmental pressures that shaped them. To accurately decode the extremes of life on Earth, we have to drop our reliance on human aesthetics and judge these forms exactly as their environments do, purely by what it takes to survive. 2,000 feet below the ocean's surface lies the twilight zone.
It is a freezing, crushing void where sunlight barely penetrates, forcing life to adopt extreme optical engineering just to locate a meal. For decades, marine biologists only knew the Barreleye fish from dead specimens dragged up in nets. Because its head appeared caved in, researchers assumed it suffered from crippling tunnel vision, its eyes locked permanently upward. Modern deepwater submersibles finally revealed the intact animal. Its head isn't caved in at all. It is encased in a completely transparent, fluid-filled dome, protecting 2 large tubular eyes that can pivot freely to look straight ahead. Those green lenses act as biological filters, blocking out residual sunlight from above so the fish can spot the faint, glowing bioluminescence of siphonophores. When the barreleye maneuvers to steal food from their stinging tentacles, the transparent dome acts as a shield. In the same blackwater abyss, the telescope fish appears equally absurd. Its eyes are extended outward on massive optical tubes, pointing directly forward instead of up. Neither facial structure is a mistake. In a lightless void with no visual reference points, pointing 2 highly sensitive tubes directly forward is the mathematical solution required to achieve true binocular depth perception. Far away from the ocean, the muddy subterranean tunnel networks of North America present a similar problem. Here, visual processing is entirely useless. To compensate, the star-nosed mole developed a face that resembles a mutated parasite. It is entirely blind, yet it is the fastest foraging mammal on the planet. This topographical map of the animal's snout shows why. Those 22 fleshy appendages are a hypersensitive somatosensory mapping organ. The structure is packed with microscopic sensors called Eimer's organs, housing an extreme density of nerve fibers. This neural density allows the mole to touch an object, verify if it is edible, and swallow it in an average of 120 milliseconds. By the time a human eye completes a single blink, the mole has already finished hunting. It even bypasses the limitations of underwater tracking. By rapidly blowing tiny air bubbles onto submerged surfaces and inhaling them a fraction of a second later, it actively smells its prey while submerged. Giving up an aesthetically recognizable face is a minor cost when the anatomical reward is a 120 millisecond reaction time in a pitch-black maze. Returning to the deep ocean, the sheer scarcity of prey requires an entirely different method of detecting the invisible. With its flabby, pale pink body and comically long, flattened snout, the goblin shark looks like a sluggish relic from a prehistoric era. But that oversized snout is a highly tuned radar dish. It is heavily lined with ampullae of Lorenzini, allowing the shark to pick up the faint, invisible electrical fields generated by the muscle twitches of fish hiding in the dark. This diagram illustrates what happens next. The shark's jaws are completely detached from the front of its skull. Instead, they are held back by elastic ligaments, storing a massive amount of tension, like a drawn bowstring. When prey drifts within range, that tension is released. The entire jaw catapults forward at up to 3.1 meters per second, engulfing the target in a fraction of a second. A sluggish profile doesn't hinder a predator when its skull operates as a high-tension, electrosensory bear trap. Far above the deep sea, the sunlit surface tension of the open ocean poses a distinct threat. Predators hunt aggressively from both the sky above and the water below. Drifting here is the blue dragon sea slug. Measuring barely an inch long, it looks like an ornate miniature dragon floated upside down on the surface. This split screen reveals the logic of its posture. By floating completely inverted, its bright blue underbelly faces the sky, blending into the ocean waves to evade seabirds. Its silver back faces the depths, reflecting the sunlight to hide it from fish below. Its delicate appearance masks its diet. It feeds on the highly venomous Portuguese man-o'-war. The slug is immune to the agony of the stings. It digests the tissue and physically harvests the still active stinging cells, pushing them out to the tips of its own appendages. By concentrating these stolen toxins in its own body, this drifting predator weaponizes the ocean's deadliest cells to dominate the surface tension. In the sweltering heat of the African papyrus swamps, the cost of survival shifts from physical camouflage to brutal efficiency. The shoebill stork stands up to 5 feet tall. With its pale yellow eyes and oversized shoe-shaped bill, it has the awkward proportions of a stone statue. That massive beak ends in a prominent curved hook, designed to slice through and crush large, heavily armored lungfish. After standing motionless for hours, the bird hunts by simply collapsing forward, using the momentum of its entire body weight to trap prey in mud. But the reality of the swamp is most visible in the bird's nest. The shoebill lays 2 eggs as an insurance policy, leading to a violent trade-off known as siblicide. Once hatched, the older, stronger chick ruthlessly attacks the younger, driving it from the nest. The parents watch this unfold and deliberately do not intervene. They withdraw all food and water from the weaker sibling, pouring every available resource into the victor. To a human observer, the parent's inaction registers as cruelty. In a resource-starved marshland, it is a strategic concentration of energy, ensuring that at least one chick survives to carry the genetics forward. From eyes encased in transparent domes to the efficiency of the swamp nest, the natural world operates on a different metric than we do. These creatures illustrate how biological forms are dictated by the immediate pressures of their environments, rather than human concepts of comfort or proportion. To thrive in environments characterized by crushing pressure, absolute darkness, or severe starvation requires trade-offs. The resulting biology will almost always look like an anomaly to us. The next time you see a creature that looks like a glitch in the system, remember that evolution doesn't miss. You are looking at millions of years of specialized adaptation, operating exactly as required.